This is Geometry Unit 9, Lesson 5, Word Problems Using Trig Functions. When you are doing word problems using trig functions, it's very, very important to draw yourself a diagram so you can see exactly what you have to do. So, let's read the problem, draw ourselves a diagram, and see if we can figure out what we have to do. When built, the Tower of Pisa stood 180 feet tall. So here's the Tower of Pisa. It's 180 feet tall. 180 feet. Okay? Hopefully it is straight up and down. And now the top is 17 feet away from the vertical. So now the tower is leaning. It's 17 feet away from the vertical. So this is the vertical. The distance it is leaning like this. The top of the tower is now 17 feet away from where it started. So the distance from here to here has shifted 17 feet. Okay? And the top is also perpendicular to the value there. Now it says, what angle to the nearest tenth of a degree does the tower make with the vertical? So here's the tower, here's the vertical. We're looking for this angle right here. Okay, so based on that information we have, remember this is SOHCAHTOA. Let's pay attention to which one we have and which one we need. Okay, from this angle, that's what we're working from, we have what sides? Well, this side is opposite. This side is adjacent, which makes us using tangent. So, tangent of x is equal to opposite over adjacent. So, opposite would be 17, adjacent is 180. So we are looking for an angle whose tangent is 17 over 180. What do we have to put in our calculator? You have to use inverse tangent. So tan inverse, 17 over 180. Go to your calculator. Second tan, 17 divided by 180. Close your parentheses. And it says round to the nearest tenth of a degree. So this is going to be 5.39 would round to 5.4. So this is approximately 5.4 degrees. So this is shifted 5.4 degrees from the vertical. And that's what we were looking for. Here's our second example. A peaked roof slopes up at an angle of 22 degrees. If the entire roof, including the eaves, is 32 feet wide, how long is each rafter to the nearest hundredth of a foot? Okay, so let's draw ourselves a picture. Here's a peaked roof. Okay, now hopefully when you have a peaked roof, it's even on both sides. So actually, what kind of triangle is this? Well, this is an isosceles triangle, like this. These two sides are equal, and that means that these two angles are equal. So this one is 22, and this angle is also 22. Now, the entire roof, including the eaves, is 32 feet wide. That's 32 feet wide. Now it says, how long is each rafter to the nearest hundredth of a foot? Now the rafter is the side of the triangle right here. It's they're put on, this is a whole rafter and this is a whole rafter. So we only want this part right here. Now if we want to use SOHCAHTOA on this, we don't have a right triangle, but could we make one? Sure we could. If we draw in a dotted line from the peak of the roof down like this rafter and this rafter are equal, making a right triangle right here. So that's going to split the whole length here into two pieces of 16 each. So I actually have two right triangles to make the whole roof. So now that I know that, what is the length of the rafter? That's what I'm looking for. Working from SOHCAHTOA. SOHCAHTOA, from my angle that I have, what sides of this triangle, this right triangle right here, do I have? Well, x is the hypotenuse, and 16 is adjacent to angle 22. So that means we have to use cosine. So cosine of A is equal to adjacent over hypotenuse. A is the angle, so that's cosine of 22. The adjacent side is 16. The hypotenuse is x. So when I solve this, I want to cross multiply and solve for x. So x times the cosine of 22 is equal to 16. Solve for x, I have to divide by the cosine of 22, so I'm going to write that down. 16 divided by cosine of 22. This is what I put in my calculator. 16 divided by cos 22. and it said round to the nearest hundredth of a foot. So 17.256 rounds to 17.26. So that means that my rafter is approximately 17.26 feet. This side is 17.26, and since these are equivalent, this is also 17.26. So there are my two rafters. Here's the last one. From the top of a lighthouse 165 feet above sea level, the measure of the angle of depression of a boat at sea is 35 degrees. Find to the nearest foot the distance from the boat to the foot of the lighthouse. Okay, now this one's got a little vocabulary in there we have to pay attention to. So, we're at the top of a lighthouse 165 feet above sea level. So here's your lighthouse. You're 165 feet up from there. And hopefully it's straight up and down because you don't want a leaning lighthouse. Now, yesterday on the notes we talked about the angle of elevation, which is looking up from a horizontal. The angle of depression is looking down from a horizontal. Okay, now that's important, looking down from a horizontal. So basically what's happening is you're standing here at the top of your lighthouse. You are looking straight out like this as a horizontal, like this. Now, it says the angle of depression, you are looking down from the horizontal. So if you are looking down from the horizontal, like this, there's a boat out here, you're looking down, your angle is actually right here. Because this is the horizontal, and then you're looking down. So the angle is actually right there. Now, it says, find to the nearest foot the distance from the boat to the foot of the lighthouse. So the boat is out here, the foot of the lighthouse is here, so we are actually looking from the distance from here to here. That's going to be my x. Problem. The 35-degree angle is outside the right triangle. But remember that this is a horizontal up here. Well, if this is looking straight out horizontal, isn't it parallel to the ground? Well, that would be down here. So if these two lines are parallel, doesn't that make this an alternate interior angle with this angle down here? Yeah, it does. So if this one's 35, that one's also 35. So now we have an angle. Now, what if we didn't know that these were alternate interior angles? What else could we do? Do we know this angle right here? Well, remember, this is a vertical, this is a horizontal. That means this makes a right angle up here. So if this is 35, how much is left for this angle here? It would be 55. All right, so let's use 35 first to make sure this works. If we use 35 from here, what sides of the triangle do we have? Well, we have opposite and we have adjacent. So let's use tangent. Tangent of A equals opposite over adjacent. So tan 35 equals 165 over x. Cross multiply, x tan 35 equals 165. To solve for x, you want to divide by the tangent of 35. So we go to our calculator, 165 divided by the tangent of 35. Close your parentheses, and you get a rounded to the nearest foot, 235.6 rounds to be 236 feet. So x is approximately 236 feet. Now, suppose I wanted to use this angle instead. If I use this angle, tangent of 55, I would use opposite over adjacent. Opposite would be x, adjacent would be 165. So x over 165. Cross multiply, x is equal to 165 times the tangent of 55. Put that in your calculator. 165 tangent 55. Look at that. We got the same answer. So it doesn't matter which angle you use. You just have to make sure you're using the correct ratio to work from that. So when you're doing word problems using Trig, draw yourself a picture, put as much information as you can on the paper, and then work out what ratio you need to use. Be very careful to round to the correct place and to answer what the question asks.